So in this problem we're asked to find the equation of a plane. As a reminder, one way to describe a plane is to write it as n1 times x minus a plus n2 times y minus b plus n3 times z minus c equals 0, where n is the normal vector and I should be more careful and say a normal vector, and ABC is a point on the plane. So let's go ahead and work this. We need to come up with a normal vector for our plane. We already know the point that it's supposed to pass through. So to come up with a normal vector, well, the only information we're given is that it needs to be perpendicular to the two planes stated, plane 1 and plane 2 here. And although these are in different forms, in both cases we can identify the normal vectors of each plane. So for plane 1, let's call this plane 1 here, and we'll call this plane 2. So plane 1 has normal vector. In this case, we can just read it off as the coefficients in front of the variables. So it's normal vector n. We'll label it n1 for the normal vector for the first plane. And its normal vector is 2, 1, minus 2. Plane 2 as normal vector n2. And in this case, we get the normal vector from this description of the plane here. Remember that one way to describe a plane is to write it as n dotted with the vector x minus a, y minus b, z minus c. That's one of the many ways to write an equation of a plane. So in this case, the normal vector of the second plane is 1, 0, 3. Our plane will have its own normal vector that is equal to the cross product and n2. Folks, order does matter with cross product, but because it doesn't matter how we orient our normal vector for this problem, it doesn't matter the order in which we write n1 and n2. So somebody doing this in a different order will get a different normal vector up to a scalar. But that doesn't matter for what we want. So anyway, our normal vector will be, we're going to take the we're going to take the cross product of these two normal vectors, and one way to think about it is by taking the determinant of I, j, k, and then for our two normal vectors, let's see here, I wrote this as n1, so n1 goes first, 2, 1, minus 2, and then the vector n2 goes in row 3, so 1, 0, 3, and let's compute that cross product. So I've gone ahead and computed that cross product, and you can see we ended up with 3i hat minus 8j hat minus k hat. So now that we've got the normal vector of our plane, all that remains to be done is to take the point that we were given and this new normal vector and state the equation. So notice that for our normal vector, here's our n1, here's our n2, here's our n3. So the equation of the plane would be 3 times x minus, and then our x coordinate is 2, plus negative 8 times times y minus 1 minus z minus 1 is equal to 0. And that completes the problem. I went ahead and simplified. You can leave this in one of many different forms, even the form that you originally had. I'd be perfectly fine with this form, or this form, or one of the many variants of how you can write the equation of a plane. That concludes that question.